Origins, the story of math from the ground up. Mathematics surrounds us. It's in the beauty of nature, the design of skyscrapers, the rhythm of music, and even the technology we use every day. But how did this incredible field of knowledge begin? And how has it grown into the universal language that powers our modern world? In this documentary, we take you on an extraordinary journey through the birth, growth, and future of mathematics. Before we dive in, remember to like, share, and subscribe to our channel to support educational content like this and to never miss an opportunity to expand your knowledge. The story of mathematics starts thousands of years ago, long before the existence of written language. Early humans relied on simple counting methods, using stones, sticks, or tally marks to track goods, animals, and seasonal cycles. These rudimentary systems laid the foundation for something far more complex. As societies grew, so did their need for structured systems of calculation. Farmers began tracking harvests, merchants kept records of trades, and timekeeping became essential. Mathematics, even in its simplest forms, was quickly recognized as a vital tool for daily life and survival. It was the spark that would ignite a global journey of discovery. The first major leaps in mathematical development came from ancient civilizations. In Babylon, early mathematicians used a base 60 number system, the remnants of which persist today in our 60-second minutes and 360-degree circles. The Babylonians were also pioneers in solving quadratic equations, one of the earliest examples of advanced math. Meanwhile, the Egyptians used geometry to achieve astonishing feats, like constructing the pyramids with precision dimensions. They also developed techniques to measure land affected by the flooding of the Nile River, creating some of the earliest applications of mathematical formulas. The Greeks elevated mathematics to an art of logical reasoning and exploration. Pythagoras, a name all math students know, discovered relationships between numbers and shapes, including his famous theorem about right triangles. Euclid, often called the father of geometry, laid out his systematic mathematical proofs in the Elements, a groundbreaking book that remains influential even today. Archimedes, another Greek genius, uncovered principles of calculus long before its formal invention and demonstrated how math could solve practical problems, such as calculating areas and volumes. For the Greeks, mathematics became more than a list of rules. It became a way to understand the nature of reality itself. A revolutionary milestone in mathematics came from ancient India, the invention of zero. Indian mathematicians like Aryabhata and Brahmagupta introduced this concept, allowing calculations to become more efficient and numbers to expand infinitely. Zero was not merely a placeholder, it was a profound idea that transformed mathematics forever. It simplified arithmetic operations and enabled the development of advanced fields like algebra. Without it, much of what we consider modern mathematics wouldn't exist. During Europe's Dark Ages, the flame of mathematical knowledge was kept alive by Arabic scholars. Mathematicians like Al-Khwarizmi, often called the father of algebra, wrote influential books that spread mathematical concepts throughout the Islamic world and eventually into Europe. Arabic numerals, which we still use today, replaced cumbersome Roman numerals and made calculations simpler. Scholars of this era also honed trigonometry and introduced techniques that would later fuel advancements in navigation, astronomy, and architecture. The Renaissance sparked a new wave of interest in mathematics, driven by its practical applications in art, science, and exploration. Visionaries like Leonardo da Vinci used geometry to perfect perspective in painting. Meanwhile, René Descartes invented coordinate geometry, blending algebra and geometry into a single system. This period also saw Galileo Galilei applying mathematics to the natural sciences, demonstrating that the universe operates on measurable principles. Mathematics became the indispensable language of discovery during this era of innovation. The 18th and 19th centuries were extraordinarily productive for mathematics. This was the era of calculus, a powerful tool independently developed by Isaac Newton and Gottfried Leibniz. Calculus revolutionized our understanding of motion, change, and the forces of nature. Statistics and probability theory also emerged during this time, offering new ways to analyze data and make predictions, a field that continues to have profound, real-world implications in economics, medicine, and beyond. The intersection of mathematics and physics brought extraordinary breakthroughs in the 20th century. Albert Einstein's theories of relativity relied on complex mathematical equations to explain the nature of space, time, and gravity. Mathematics also became essential for astronomy, providing the tools to predict planetary motion and explore distant galaxies. At this time, math truly proved its place as a universal language for understanding the cosmos. The mid-20th century witnessed another groundbreaking moment in math: Alan Turing's work on algorithms. His mathematical machines laid the foundation for modern computing, setting the stage for the computers and smartphones we use today. Algorithms, fueled by mathematics, are the building blocks of computer science. They power everything from search engines and social media to intricate simulations in research and engineering. Fast forward to today, and mathematics continues to drive innovation through artificial intelligence, AI. Using statistical models and machine learning algorithms, math helps computers recognize patterns, analyze massive data sets, and even mimic human reasoning. From transforming healthcare to creating self-driving cars, AI demonstrates how mathematics is not only a reflection of the past, but a pathway to the future. One of the most captivating aspects of math is how it appears in nature. Patterns such as the Fibonacci sequence can be found in flowers, seashells, and galaxies. Fractals, self-repeating structures, describe the beauty of mountains, clouds, and coastlines. These natural patterns show that math isn't just something humans invented, it's a part of the universe itself. Across cultures and continents, math speaks one common language. Whether solving a puzzle in algebra or calculating distances in physics, the principles of mathematics remain consistent. It transcends differences in culture, geography, and even time periods. This universality not only connects us to one another, but also to the past thinkers whose discoveries paved the way for modern advancements. What's next for mathematics? As we face challenges like climate change, renewable energy, and space exploration, math will undoubtedly be at the forefront of finding solutions. Simulating the Earth's climate, engineering more efficient technology, and planning human missions to Mars all rely on advanced mathematics. The future of math is as infinite as the numbers it studies. And with new discoveries on the horizon, students like you might be the ones to write the next chapter in this story. Here's the truth: math is for everyone. It's not something reserved for geniuses or limited to classrooms. Every time you measure, calculate, or solve a problem, you're engaging in math. It's less about memorizing formulas and more about developing the ability to think logically and creatively. Don't let the myths about math stop you. Embrace it as the exciting and essential tool that it is. As we end this journey through the birth and evolution of mathematics, think about how math is a part of your life. From securing better grades at school to building cutting-edge technologies, math offers countless opportunities for growth and exploration. If you've ever struggled with or felt distant from math, let this story inspire you. Remember, the powerful ideas of zero, algebra, calculus, and AI all started with simple discoveries. Who knows what contributions you might make to this universal language? Thank you for watching the story of math from the ground up. If you enjoyed this journey, don't forget to like, share, and subscribe to our channel. Keep learning, keep exploring, and keep solving the problems of tomorrow using the timeless power of mathematics.